Dear students, welcome to this lecture series on 8051 microcontroller, and today we'll be talking about the memory organization of the 8051 microcontroller. It's quite important topic, and you have to have a very sound understanding of the memory organization in order to use the microcontroller effectively. Okay, so uh, memory of 8051 is basically two types of memory are there, RAM and ROM. Okay, uh, the ROM memory is also called the program memory, and this is the area where the program and the codes that are written at 8051 are saved, while the RAM is the data memory wherein the data is saved. And the program memory is a non-volatile permanent memory. You do not want the program to get erased when the microcontroller is turned off or switched off or reset. Okay, you want the program to stay there, while you don't care much about the data that are being used in the program. So they are stored in data memory, and once the microcontroller is reset or the microcontroller is turned off, the memory just gets vanished. So let's move forward. So the program memory or the ROM. Okay, so this is as I told you, is the permanent memory, and where the program or the code is saved. It is also the read only memory. That means you cannot make changes to the ROM once the program is burned in ROM, so no changes are allowed. Okay, and depending on the settings made in compiler and program memory, 8051 can store some constant variables also in 8051 in ROM. Sorry, in ROM. So if you remember, I had told you that there are certain constants which need to be saved permanently for some applications. For example, take the case of traffic light. Okay, so there are numbers that are displayed, and after so certain interval of time the number changes. So those numbers 1 2 3 4 and so on, they are basically having some codes, and they are saved in the ROM. Okay, and that information need to be stored permanently so that it can be accessed by the program in due course of programming. Okay, so 8051 executes only the stored memory, stored program in the ROM. Okay, so there are 4 kilobytes of internal ROM, as well as we have an option of connecting 64 kilobytes of external ROM. So let's see how that is done. So ROM can be used in 3 ways. So if you are interested using only the internal ROM, so 4 KB area is available for that. The memory address location starts from your 0000H to 0FFFH. Okay, so in most of the application, this much amount of memory location is sufficient for a particular application. Okay, you must be wondering why now we are having uh, memories, ROM memories of the order of gigawatts, gigabytes, and I'm talking about only 4 kilobytes. How can it be sufficient? You see, microcontrollers are application specific. Okay, so in any of the general application you see around you, traffic lighting or your washing machine or speed control of any motor and things like that, they don't require thousands of instructions for carrying out the application. Normally 300 400 instructions are sufficient to carry on the application. Okay, so that 4 KB is sufficient for writing the for doing some particular application. But they do have the 8051 do have the option to enhance that 4 kilobytes of ROM, and additional total 64 kilobytes of ROM can be added to 8051. Okay. Now there are two ways to do it. Either you use the internal ROM as well as the external ROM, or you use only the external ROM. Okay. So you must be wondering why there is a need to use only the external ROM. So at times when you want to upgrade the system, then you want to discard whatever there is in the internal ROM. You do not want it. Okay. And definitely you cannot erase it. So just don't bother about it. You can connect externally 64 kilobytes of ROM and program it and use it as and when the demand of the application. Okay. So the memory addressing in the two cases will be done as shown here. Okay. So it starts from 000H and it goes till FFFFH. Okay. From 000H to 0FFFH is the internal ROM, 4 KB internal ROM, while from 1000H to FFFFH is the 60 kilobytes. It is 60 kilobytes. 60 kilobytes of external ROM. Okay, in total it can only be 64. Why? I have written it here. You see the address bus size is 16 bits. Okay, so at most the number of addresses that can be accessed by the address bus is 2 to the power 16. So 2 to the power 16 is basically 2 to the power 6 into 2 to the power 10. Okay, so 2 to the power 6 is 64 and 2 to the power 10 is basically 1000, around 1000. So 64 kilobytes of address is available for the 8051. External ROM can be added. Similarly, you can use entirely only the external ROM. Okay, so how to distinguish? So that is done by the help of the EA bar pin. So EA bar pin is available in the it is one of the pin of the 8051. You know that 8051 is having 40 pins and one of the pin is EA bar. So EA is basically enable external access. So whenever it is 1, that means you want to use internal ROM. And when memory location is from 000H to 0FFFH, that would mean that internal ROM needs to be accessed, while if memory location is somewhat other than more than 0FFF, like say 3000H, so that will automatically mean that it is an external ROM. While when EA bar is equal to 0, that would mean here, that would mean that you want to use only the external ROM. Okay, so the memory location from 000H to FFFFH basically refer to the external ROM address only. Okay, I hope that is clear. So EA bar equals to 1, you mean to use internal or internal and external ROM, and if EA bar is equal to 0, you are interested in using the external ROM. Okay, so this is what I have already told. So if you want to use only the internal ROM, 4 KB space is available, sufficient for most application. Address start from 0000 to 0FFF, and any address beyond that is invalid. Then the external and internal ROM both can be used. 4 KB is available for internal, 60 for external. In all 64, address starts from this to this for internal and this to this for the external. EA bar needs to be 1 here also. External ROM 64 kilobytes available, and it is required when system upgradation is a requirement. Address is from 000H to FFFFH, and here EA bar needs to be 0. So let's talk about RAM now. RAM, although it is only 256 bytes of memory, but it is very important, and we will be looking into the detail of RAM now. So 256 bytes is basically divided into two parts, the lower 128 bytes and the upper 128 bytes. Remember, this is the space where you are interested in storing data. Okay, and this is a temporary memory. This is a temporary memory. Okay, so let's see the organization. This is your internal ROM memory organization. So these are lower 128 bytes and the upper 128 bytes. Lower 128 byte address is from 000h to 7fh. Just remember that since RAM is 256 bytes, so 8 bit address is sufficient. Actually 8 bit is required to access all the memory locations of RAM. Okay, and if you remember that data bus is 8 bit wide, so at most the memory addresses that can be accessed is 2 to the power 8, 256. Okay, not more than. So from 00h to 1fh, this area, okay, these are having basically the general purpose registers in 4 banks: bank 0, bank 1, bank 2 and bank 3. And each of these banks are having 8 general purpose registers from R0 to R7. Okay, so bank 0 is also having register R0 to R7, bank 1 is also having register from R0 to R7, similarly bank 2 and bank 3. So how to distinguish whether an R0 register is of bank 0 or bank 1 or bank 2 or bank 3? That is done with the help of an SFR, which is called PSW, program status word. There are 2 bits of PSR, and when you program it 00, then bank 0 is selected, 01 means bank 1 is selected, 10 means bank 2, and 11 means bank 3 is selected. So that need to be incorporated in the program itself for the selection of a particular register of a particular bank. Then we have memory from 20h to 2fh. So this is 16 byte of memory, and most important thing is that it is a bit addressable memory location. Okay, that means each of the bit is having an address. Here each of the bit is having a register. I have zoomed this area. So in all there are 16 bytes of memory, and each of the bits, just see, each of the bits is having an address. So 00 is here also, 00 is here also, 00 pertains here, 00 pertains to bank 0 register, that is R0, and here 00 pertains to the bit address, the first bit address area. How to distinguish between the two? So they are distinguished by the instruction that is being used. Okay, so bit instruction will operate on the bit addressable area, while byte instruction will operate on the byte, the registers R0, R1, R, like move instruction is a byte instruction. So you cannot use byte instruction for bit addressable area. Bit instruction will be used there. Okay, now the memory location from 30h to 7fh. Okay, so 80 bytes of space is there, and this is again for general purpose. These are again registers, and remember they are not bit addressable. Okay, so each of them are 8 bit wide, each of them are having some address. Okay, so they can be accessed, and user can use them for his purpose during a program. Then the memory location from 80h to 7FFH, 80h to FFH. This is the memory part of the RAM wherein the SFR is saved, the special function register. So SFR, like your accumulator is there, program status word, B register is there, then some other SFR which are associated with timers, then some SFRs associate serial communication, some are associated with timers. There are many, and we'll be discussing about the SFRs in another video. They are very important concept. SFR, if you know SFR, how they work, half of the microcontroller is done. Okay, so please ensure that you have a very thorough understanding of the function of SFR. Okay, you don't have to remember its function, but you need to understand how they work. So that is more important. So this is all about the internal memory organization of 8051. If you have any doubt, query, do let me know. Okay, so we come to the end of today's lecture.